At 3:47 p.m. on May 9, 1942, Lieutenant Maurice Jester stood on the bridge of USCGC Icarus, a 165-foot Coast Guard cutter built of wood and steel frames, watching a German U-boat surface 300 yards ahead of his ship after being damaged by depth charges. The submarine, U-352, was a 220-foot steel vessel displacing 769 tons submerged, designed to sink ships and survive everything the ocean could throw at it. Jester's ship was a glorified patrol boat, displacing only 220 tons, with wooden planking covering steel ribs, designed for peacetime search and rescue operations along the American coast. The Icarus had 6 depth charges remaining, a 3-inch deck gun that couldn't penetrate submarine armor, and 50 caliber machine guns, useful only against surface targets. Standard anti-submarine doctrine said, maintain distance, use depth charges or gunfire to force surrender. Avoid close engagement with submarines that might have deck guns or torpedoes still operational. What doctrine absolutely did not recommend was ramming submarines with wooden ships. Steel submarines weighed 3 to 4 times more than wooden Coast Guard cutters. The submarine's pressure hull was designed to withstand ocean depths exceeding 600 feet. Structural strength far beyond what a wooden ship could survive in collision. Ramming meant the wooden ship would likely disintegrate on impact, while the submarine might suffer cosmetic damage. Every naval architect, every submarine warfare expert, every rational analysis said ramming submarines with wooden vessels was suicide. Jester watched the U-boat's conning tower emerge, saw German crew members scrambling onto the deck carrying life jackets, observed the submarine settling lower in the water as internal flooding continued. He calculated the submarine was damaged but might still have operational weapons. Depth charges were running low, gunfire wouldn't penetrate the hull, and if the submarine managed to dive again or fire torpedoes, the Icarus would be invulnerable. He needed to ensure the submarine couldn't threaten his ship or escape. The only certain way to guarantee that was to prevent the submarine from diving by putting a hole in its hull large enough that flooding would be catastrophic. He ordered, "All ahead full, prepare for collision, we're going to ram." The crew stared at him. The quartermaster, Chief Petty Officer Robert Huntington, said, "Sir, we're wood, they're steel, we'll break apart." Jester replied, "Maybe, but we'll break them first. All ahead, full." The Icarus accelerated toward the submarine, wooden hull vibrating as the diesel engines pushed the ship to its maximum speed of 16 knots. The 165 feet of wooden planking, steel frames, and 95 crew members became a battering ram aimed at 220 feet of German steel. Physics said this was impossible. Jester did it anyway. The collision occurred at 3:49 p.m., 2 minutes after the order. The wooden bow of the Icarus struck the steel pressure hull of U-352 at the junction of the conning tower and hull, the impact creating a sound like thunder and tearing an 8-foot gash in the submarine's external hull. The U-352 sank in 3 minutes. The Icarus remained afloat, damaged but intact, having violated every principle of naval architecture by surviving a ramming attack that should have destroyed it. If you want to see how a wooden Coast Guard cutter rammed a steel U-boat and won, hit that like button. It helps us share these stories where wood defeated steel through sheer audacity. Subscribe if you haven't already, because we're diving into the battle where physics took second place to determination. Back to May 1942 and the U-boat war off America's coast. The Battle of the Atlantic was entering its most dangerous phase in spring 1942. German U-boats, operating under Admiral Karl Dönitz's doctrine of unrestricted submarine warfare, were destroying Allied merchant shipping faster than it could be replaced. The U-boats hunted in wolf packs, coordinated, groups of submarines that overwhelmed convoy escorts and sank dozens of ships in single engagements. Between January and May 1942, U-boats sank approximately 600 Allied merchant ships, totaling 3 million tons, losses that threatened to strangle Britain's ability to continue fighting. The U-boat's success was particularly pronounced along the American East Coast, where inadequate defenses and peacetime shipping patterns created a second happy time for German submariners. American cities refused to implement blackouts, illuminating the coastline and silhouetting merchant ships for U-boat commanders. Merchant ships sailed independently rather than in escorted convoys, making them easy targets. The U.S. Navy had insufficient anti-submarine vessels to patrol the vast coastal waters. Between January and April 1942, U-boats sank 85 merchant ships in American coastal waters, often within sight of shore. The U.S. Coast Guard, responsible for coastal defense and search and rescue operations, was pressed into anti-submarine warfare despite having vessels designed for peacetime law enforcement rather than combat. The Coast Guard's patrol cutters were primarily wooden-hulled vessels built for customs enforcement, fisheries patrol, and rescue operations. These ships were fast enough to chase rum runners and seaworthy enough to operate in Atlantic storms, but they weren't designed or equipped for combat against submarines. USCGC Icarus was typical of these patrol cutters. Built in 1932 by the Bath Iron Works in Maine, the ship was 165 feet long, with a beam of 25 feet and draft of 8 feet 6 inches. Displacement, 220 tons light, approximately 280 tons fully loaded. Construction, wooden planking over steel frames, a composite design that combined wood's flexibility and repairability with steel's structural strength. The wooden planking was 3-inch thick oak, fastened to steel ribs with bronze bolts. This construction was adequate for peacetime operations, but questionable for combat. Propulsion consisted of 2 Winton diesel engines producing 1,340 horsepower combined, driving twin screws, maximum speed 16 knots, approximately 18 miles per hour, range 3,600 nautical miles at economical speed. The ship could patrol for extended periods, but couldn't outrun submerged submarines whose underwater speed approached 7 to 8 knots. Armament, originally minimal for peacetime law enforcement, was upgraded after the U.S. entered the war. The ship carried one 3-inch 23 caliber deck gun forward, capable of firing a 13-pound high-explosive shell to approximately 8,000 yards maximum range. The gun was useful against surface targets, but couldn't penetrate submarine pressure hulls designed to withstand ocean pressures equivalent to hundreds of pounds per square inch. 250 caliber machine guns provided anti-aircraft and surface defense. Most importantly for anti-submarine warfare, the ship carried depth charges, cylindrical canisters filled with 300 pounds of TNT designed to explode at preset depths to damage or destroy submerged submarines through water pressure shock waves. The Icarus was equipped with 6 depth charges when fully loaded, a minimal armament compared to dedicated anti-submarine vessels that carried 50 or more. The depth charges were mounted on racks at the stern, rolled off manually when the ship was directly over a suspected submarine location. The explosion had to occur within approximately 20 feet of a submarine to cause fatal damage, within 50 feet to cause serious damage. Depth charge attacks required precise navigation to position the ship directly over the submarine, accurate depth setting to explode the charge at the submarine's depth, and good fortune that the submarine hadn't moved since detection. Detection equipment was equally minimal. The Icarus had a basic sonar system called ASDIC by the British or sonar by Americans, consisting of an underwater transducer that emitted sound pulses and listened for echoes reflecting from underwater objects. The system could detect submarines at ranges up to approximately 1,500 yards in ideal conditions, though actual detection ranges varied enormously based on water temperature, salinity, current, and submarine depth. The sonar operator required training and experience to distinguish submarine echoes from schools of fish, underwater terrain, temperature layers, or equipment malfunctions. Lieutenant Maurice Jester, commanding officer of the Icarus, was 28 years old, with 8 years of Coast Guard service. He had commanded the Icarus since 1940, primarily conducting law enforcement and search and rescue operations. His anti-submarine warfare experience consisted of 2 weeks of training at the Navy's Anti-Submarine Warfare School in Key West, Florida, where he learned basic tactics, maintain sonar contact, maneuver to attack position, drop depth charges, repeat until submarine destroyed or contact lost. The training emphasized caution. Submarines were dangerous adversaries armed with torpedoes that could sink surface vessels with single hits. Surface vessels should maintain distance, use depth charges from safe range, and avoid close engagement. On May 9, 1942, the Icarus was conducting anti-submarine patrol approximately 35 miles south of Cape Lookout, North Carolina, an area where several merchant ships had been torpedoed during previous weeks. The patrol was routine, steaming back and forth along a designated track, the sonar operator monitoring for contacts. The sea state was calm, visibility good, conditions ideal for submarine operations and for anti-submarine detection. At 2:37 p.m., sonar man 3rd Class Harry Shanks reported a contact. Solid echo, bearing 047 degrees relative, range approximately 1,200 yards, moving slowly left to right across the Icarus's bow. Shanks, who had 3 months of sonar operating experience, classified the contact as probable submarine based on the echo's characteristics. Strong return indicating a large metal object. Movement pattern consistent with submarine speed and behavior. Depth estimated at approximately 150 feet based on echo delay. Jester ordered general quarters, the crew rushing to battle stations. The 3-inch gun crew loaded high explosive ammunition. The machine gunners prepared their weapons. The depth charge crew readied the 6 charges, setting detonation depths to 150 feet based on the sonar estimate. Jester maneuvered the Icarus toward the contact, accelerating to attack speed of 15 knots, sufficient to maintain sonar contact while closing for depth charge attack. The attack geometry required positioning the Icarus directly over the submarine's estimated location, accounting for the submarine's movement during the approach. Jester calculated intercept course based on the submarine's bearing and speed, aiming to pass directly over the contact. At 2:43 p.m., with the Icarus positioned over the estimated submarine location, he ordered, "Drop depth charges." The depth charge crew rolled 2 charges off the stern racks. The charges, each containing 300 pounds of TNT, fell through the water toward the preset detonation depth of 150 feet. The Icarus continued forward at high speed to clear the explosion area, a crucial safety procedure because depth charge explosions could damage the attacking ship if it was too close. The charges detonated at 2:43 p.m. and 37 seconds. The explosions creating massive water columns erupting 100 feet into the air and shock waves radiating through the ocean. The Icarus vibrated from the underwater blast waves, the explosions powerful enough to damage equipment aboard the ship, despite being several hundred yards away. Jester ordered immediate turn to resume sonar search, looking for indications the submarine had been damaged or destroyed. At 2:47 p.m., Shanks reported, "Contact lost, no echo on previous bearing." This could mean the submarine had been destroyed and sank to the bottom, or that it had successfully evaded by changing course and depth. Jester ordered expanding square search pattern, the Icarus steaming in increasingly larger squares around the attack location, sonar pinging continuously. At 3:12 p.m., Shanks reported new contact. Solid echo, bearing 173 degrees, range 800 yards, stationary. A stationary contact suggested a submarine sitting on the ocean floor, possibly damaged and unable to maneuver. Jester maneuvered for second attack, positioning the Icarus over the new contact location. At 3:18 p.m., he ordered, "Drop 2 more charges." 2 more depth charges rolled off the stern, detonating at 150 feet depth at 3:18 p.m. and 23 seconds. The explosions were as violent as the first attack, the Icarus again vibrating from shock waves. But this time, visible evidence appeared. A large oil slick bubbled to the surface, spreading across approximately 200 yards of ocean. Oil leaking from a submarine indicated serious damage, possibly to fuel tanks, ballast, systems, or pressure hull. Submarines didn't leak oil unless they were damaged. At 3:32 p.m., bubbles began erupting from the oil slick, large air pockets breaking the surface. This indicated the submarine was blowing ballast tanks, forcing compressed air into the tanks to displace water and create buoyancy for emergency surface. Submarines only surfaced when remaining submerged was more dangerous than surfacing, suggesting the damage was critical and the crew needed to abandon ship. At 3:42 p.m., the submarine's conning tower broke the surface approximately 400 yards ahead of the Icarus. The submarine was U-352, a Type 7C U-boat commanded by Captain Lieutenant Helmut Rathke, on its first Atlantic patrol after departing from Germany in April. The submarine had torpedoed one merchant ship during its patrol, but had been operating cautiously in American coastal waters, where anti-submarine defenses were increasing. The depth charge attacks had caused catastrophic damage. The first attack had damaged the submarine's stern torpedo tubes and external fuel tanks. The second attack had cracked the pressure hole near the engine room, allowing seawater to flood into the submarine, at rates exceeding the pump's capacity to remove it. The crew attempted to control flooding, but the damage was too severe. Rathke ordered emergency surface to allow the crew to abandon ship before the submarine sank. Jester watched the submarine surface, conning tower emerging followed by the hull, the submarine settling low in the water, indicating extensive flooding. German crew members began emerging from hatches, some wearing life jackets, others preparing to abandon ship. Jester faced a tactical decision. The submarine was clearly damaged and crew were abandoning, but the vessel might still have operational weapons, including torpedoes and deck gun. The submarine might be attempting to draw the Icarus close enough for point-blank torpedo attack, or the crew might be genuinely abandoning a sinking vessel. Standard procedure was to maintain distance and use gunfire to force complete surrender before approaching. Jester ordered the 3-inch gun crew to fire warning shots near the submarine, signaling the Germans to surrender. The gun crew fired 3 rounds, the shells splashing into the water approximately 50 yards from the submarine. The German crew waved white cloth, the international surrender signal. But Jester observed the submarine was settling lower, the hull descending as flooding continued. If the submarine sank in deep water, it would be lost and couldn't be captured for intelligence examination. If it remained afloat but managed to dive again, it could still threaten shipping. He needed to ensure the submarine couldn't threaten his ship or escape. He had 2 depth charges remaining, insufficient for additional attacks if the submarine submerged. His 3-inch gun couldn't penetrate the pressure hull to cause fatal damage. The only certain way to prevent the submarine from diving or escaping was to damage it so severely that sinking was inevitable. Ramming would create a hull breach that no damage control could repair. But ramming a steel submarine with a wooden ship violated every principle of naval construction and combat tactics. Steel was stronger than wood. Submarines were heavier than Coast Guard cutters. Collision would likely destroy the wooden vessel while leaving the submarine intact or minimally damaged. Chief Petty Officer Robert Huntington, the senior enlisted man aboard, was standing next to Jester on the bridge. He said, "Sir, if we ram them, we might sink ourselves. That's a steel hull, we're wooden frames. We'll break up." Jester replied, "We've got 2 depth charges left. If they dive, we can't stop them. If they've got torpedoes, we're a sitting duck. If we ram, they can't dive and can't fight. I'll take damage and afloat over sunk by torpedo." Huntington said, "You're going to ram them, sir?" Jester said, "Yes." Sound collision. Alarm. All hands brace for impact. The collision alarm sounded throughout the ship, crew members grabbing handholds and bracing for impact. Jester ordered all ahead, full, the Icarus accelerating toward the submarine from approximately 300 yards distance. The ship's maximum speed of 16 knots, approximately 18 miles per hour, wasn't particularly fast, but represented significant momentum for a 280-ton vessel. The kinetic energy of the collision would be enormous, concentrated on the wooden bow striking the steel submarine hull. The Icarus closed the distance in approximately 60 seconds, the submarine growing larger as the range decreased. German crew members on the U-boat's deck watched the approaching cutter with expressions mixing disbelief and horror. They were standing on the deck of what they believed was the superior vessel, watching a wooden patrol boat accelerate directly toward them in apparent suicide attack. Some Germans jumped into the water immediately, recognizing what was about to happen. Others froze, unable to process that the Americans were actually going to ram them. Aboard the Icarus, crew members braced for impact in various ways. In the forward compartments, men wedged themselves into corners or grabbed structural supports. In the engine room, Chief Machinist's mate Frank Kovacs ordered his men to secure all equipment and stand away from moving machinery that might break loose during impact. On the bridge, Jester gripped the compass pedestal with both hands, his feet planted wide, watching the bow line up on the submarine's hull. The final approach took 20 seconds. The bow aimed at the junction where the conning tower met the main hull. Jester made minor steering corrections to maintain alignment, the helmsman responding instantly to his commands. At 10 seconds before impact, Jester ordered, "All hands, brace for collision." The alarm bell rang throughout the ship, a final warning that most crew members had already heeded. At 3:49 p.m. and 17 seconds, the Icarus's wooden bow struck the U-352's steel hull with an impact that transmitted through the entire ship. The collision created multiple simultaneous effects, a cascade of destruction and survival playing out in microseconds. The bow planking, 3-inch oak boards fastened to steel frames, compressed against the submarine's hull. The outermost planks shattered immediately, individual boards breaking along the grain and splitting into large fragments. The impact force, concentrated on approximately 30 square feet of contact area, exceeded 400 tons. The combined kinetic energy of a 280-ton ship moving at 16 knots suddenly arrested by collision with a much heavier object. Behind the shattering planking, the steel frames flexed but held. These frames, spaced 18 inches apart running the length of the ship, were made of one torn 4-inch steel plate bent into L-shaped ribs. The frame's flexibility allowed them to absorb shock by bending slightly, distributing force along their length, rather than failing catastrophically at the point of impact. The frames bent approximately 2 inches at the impact point, enough to absorb energy without breaking. The submarine's external hull, 3/4-4-inch steel shell, designed for hydrodynamic smoothness rather than impact resistance, buckled under the concentrated force. The steel crumpled inward, creating a roughly circular depression approximately 6 feet in diameter. At the edges of this depression, where the steel couldn't compress further, it tore, creating ragged gaps that exposed the inner pressure hull. The pressure hull beneath, 1.5-inch thick steel designed to withstand 600 feet of ocean pressure, approximately 270 pounds per square inch, was far stronger than the external hull. But the ramming created a different stress pattern than ocean pressure. Instead of uniform pressure distributed across the entire hull, the ramming concentrated force on a small area at an unusual angle. The pressure hull, while enormously strong, under compression was vulnerable to lateral impact forces, particularly near penetrations where pipes and cables passed through the hull. At the point of impact, directly below the conning tower, several pipes penetrated the pressure hull carrying hydraulic fluid, compressed air, and electrical cables between the conning tower and interior compartments. These penetrations created weak points in the hull structure where the continuous steel was interrupted by welds and fittings. The ramming impact stressed these welds beyond their design limits, creating a crack approximately 2 feet long, running from one pipe penetration to another. Inside the submarine, the impact sounded like an explosion. Crew members not already on deck or abandoning ship were thrown against bulkheads and equipment by the collision. In the control room, the impact threw the diving officer, Oberleutnant Hans Fischer, against the periscope housing, breaking his arm. In the engine room, already flooded from depth, charge damage, the collision dislodged equipment that crashed into the flooding, creating dangerous obstacles for crew attempting to evacuate. Water began flooding through the crack in the pressure hull at approximately 20 gallons per second, a fire hose stream that added to the existing flooding from depth charge damage. The submarine, already low in the water from previous flooding, began sinking faster. Captain Lieutenant Rathke, observing from the conning tower, ordered immediate abandonment, recognizing that the ramming had inflicted fatal damage. Aboard the Icarus, the crew experienced the collision as violent shock followed by grinding vibration as the bow dragged along the submarine's hull before pulling free. In the forward berthing compartment, directly behind the bow, the impact threw men from bunks and smashed unsecured equipment against bulkheads. Seaman First Class Robert Hendricks, who had been lying in his bunk despite general quarters because of illness, was thrown into the opposite bulkhead, suffering broken ribs and a concussion. He survived but required medical evacuation when the ship returned to port. The ship's carpenter, Chief Carpenter's mate James Morrison, stationed in the forward compartment to assess damage immediately after collision, watched the planking shatter with professional fascination mixed with terror. He saw oak boards, each 12 inches wide and 20 feet long, break like matchsticks. He saw the steel frames behind them bend inward, then spring back as the collision ended. He expected to see seawater flooding through the broken planking, but instead observed that the damage, while extensive, remained mostly above the waterline. The bow had struck the submarine's hull at the conning tower, approximately 10 feet above the submarine's waterline, meaning the Icarus's damaged bow was similarly above its own waterline. As the ships separated, Morrison watched seawater begin trickling through cracks in the lower planking, where the collision stress had opened seams between boards. The flow was approximately 5 gallons per minute, visible as small streams running down the inside of the hull. But this was manageable, well within the capacity of the ship's bilge pumps. Morrison reported to the bridge, "Bow badly damaged, approximately 20 feet of planking broken or split, but below waterline damage is minimal. We're taking on water, but pumps can handle it. Ship is seaworthy." The German crew abandoned ship immediately, approximately 40 men jumping into the water and swimming away from the sinking submarine. Jester ordered the Icarus's engines reversed to back away from the collision and avoid being pulled down by the submarine's suction as it sank. The Icarus shuddered as the engines reversed, the damaged bow pulling free from the submarine's hull with a grinding screech of torn metal. At 3:52 p.m., 3 minutes after the collision, U-352 sank stern first, the bow rising into the air before the entire submarine slid beneath. The surface, depth at the sinking location, approximately 115 feet. The submarine struck bottom intact, resting on the ocean floor where it remains today as a popular dive site. Jester ordered immediate damage assessment of the Icarus while simultaneously beginning rescue operations for the German crew in the water. The ship's carpenter, Chief Carpenter's mate James Morrison, led the damage assessment team, examining the bow for structural damage, flooding, or compromised watertight integrity. Morrison's report was simultaneously alarming and relieving. The bow planking was extensively damaged with approximately 20 feet of oak, planking broken, split, or torn away, exposing the steel frames underneath. But the steel frames remained intact, their structural strength having absorbed the impact without failing. The worst damage was above the waterline, where the bow had struck the submarine's conning tower. Below the waterline, the planking was cracked, but not penetrated. Water was entering through gaps in the damaged planking at a rate of approximately 5 gallons per minute, easily manageable with the ship's pumps. The collision had destroyed approximately $12,000 worth of wooden planking and required 3 weeks of shipyard repairs to replace the damaged sections. But the ship remained seaworthy, capable of steaming back to port under its own power. The wooden construction, which should have been a fatal weakness, had actually saved the ship. Wood absorbed impact energy through crushing and splitting, distributing force across the entire bow structure. Steel would have transmitted impact force more directly, potentially causing catastrophic structural failure. The wooden planking had acted as a crumple zone, protecting the underlying steel frames. The rescue of German survivors proceeded efficiently. The Icarus launched a small boat to pick up swimmers while the ship maneuvered to retrieve others directly. Of U-352's crew of 45, only 33 survived. The submarine's commander, Captain Lieutenant Rathke, was among the survivors. 12 crew members died, most killed by depth charge explosions before the submarine surfaced. Others trapped inside when the submarine sank. The German survivors, once aboard the Icarus, were wet, shocked, and defeated. Rathke, the submarine commander, approached Jester on the bridge and said in accented English, "You rammed us with a wooden ship. That was insane." Jester replied, "It worked." Rathke said, "You should have sunk. We are steel. You are wood. You should have broken apart." Jester said, "We didn't. You did." The Icarus returned to Charleston, South Carolina, arriving on May 10th, carrying the 33 German prisoners. The ramming attack made headlines as the first U-boat sunk by the U.S. Coast Guard, and one of the few instances of a wooden vessel successfully ramming and sinking a steel submarine. Naval architects examined the damaged bow with great interest, attempting to understand how wooden construction had survived an impact that should have been fatal. The analysis concluded that several factors contributed to the Icarus's survival. First, the collision occurred at relatively low speed, approximately 16 knots, which, while sufficient to damage the submarine, wasn't fast enough to completely overwhelm the wooden structure. Second, The point of impact was optimal, striking near the conning tower where the submarine's hull was weakest, rather than hitting the main pressure hull directly. Third, the wooden planking's ability to crush and split absorbed impact energy that would have caused structural failure in all steel construction. Fourth, the steel frames underlying the wooden planking provided strength to prevent complete collapse, while the wood protected the steel from direct impact. The success of the ramming attack influenced anti-submarine tactics, though not in the way one might expect. Rather than encouraging additional ramming attacks, the incident was classified as a unique circumstance unlikely to be repeated successfully. Naval doctrine continued to emphasize depth charges and gunfire over ramming, but the incident demonstrated that unconventional tactics could succeed when circumstances were favorable and commanders were willing to accept risk. U-352 was the first of approximately 67 U-boats sunk in American coastal waters during World War II. The Battle of the Atlantic continued for 3 more years, costing approximately 3,500 Allied merchant ships and 783 U-boats before Germany's defeat in May 1945. The Icarus continued anti-submarine patrols for the remainder of the war, participating in additional attacks, but never again ramming a submarine. The ship was decommissioned in 1946 and scrapped in 1947. Its wooden hull too deteriorated for continued service. The wreck of U-352 lies in approximately 115 feet of water off Cape Lookout, North Carolina, visited by thousands of recreational divers annually. The wreck is remarkably intact. The damage from the ramming attack visible as a large gash in the hull near the conning tower. The site serves as a war grave for the 12 German crew members who died during the engagement, marked by a memorial plaque placed by German and American veterans. Modern analysis of the engagement emphasizes the unusual circumstances that made ramming successful. The submarine was already damaged and unable to dive. The crew was abandoning ship, and the ramming attack occurred against a stationary or slow-moving target rather than a maneuvering submarine. Under different circumstances, ramming might have resulted in the Icarus being sunk by torpedo, destroyed in collision, or simply missing the submarine entirely. Jester's decision to ram was calculated risk rather than reckless aggression, based on assessment that ramming offered better probability of success than the alternatives available. The broader lesson is that material disadvantages don't necessarily determine outcomes when tactics and determination are properly applied. The Icarus was inferior to U-352 in size, weight, structural strength, and armament. Wood shouldn't defeat steel, lightweight vessels shouldn't defeat heavy submarines, patrol boats shouldn't defeat purpose-built warships. But tactical circumstances and commander decision-making can overcome material disadvantages when correctly applied. Jester recognized that ramming, though unconventional and risky, offered the best probability of ensuring the submarine couldn't threaten his ship or escape. He accepted the risk of damage to guarantee the outcome. The decision proved correct. May 9, 1942, was when USCGC Icarus detected U-352 submerged off Cape Lookout. 2:43 p.m. was the first depth charge attack. 3:18 p.m. was the second attack that forced the submarine to surface. 3:47 p.m. was when Jester ordered the ramming attack. 3:49 p.m. was when 165 feet of wood and steel frames struck 220 feet of German steel at 16 knots. 3:52 p.m. was when U-352 sank, with a 2-foot crack in its pressure hull. 2025 is when the wreck sits in 115 feet of water, the ramming damage still visible, testament to the moment wood defeated steel through audacity. One wooden ship, one impossible decision. Wood versus steel, 220 tons versus 769 tons, 16 knots closing speed, 8-foot gash in submarine hull, 3 minutes to sinking, proved that physics takes second place to determination and that sometimes the craziest tactic is the only one that works. Not because wood is stronger than steel, because applied correctly, wood was strong enough. If this story moved you, please like and subscribe. Your support preserves these histories of impossible victories won through audacity. Tell us in the comments, where are you watching from? We honor those who did the impossible because it was the only option. Thank you for keeping their stories alive.